that rigged a tweeter Frankenstein monster that should have never existed, that I shall call, for lack of imagination, the Abomination, or the more badass term, the Abominator. Okay, so anyway, the purpose of it is that this tweeter happens to be the perfect size that it's able to test all new Kef Uniques and all old Kef Uniques. It has all the same principles as the new Kef Uniques, including it supports the full-on this guy. And I showed the video before of it, my little quiz of, can you tell this thing works? And if you follow through the little test, you can see that it definitely did work. But what's cool is that you could actually use even like the older horn tweeters, or I guess horn snouts. We never really came up with a good name for all of these things. And see how it affects the frequency response. So I'm actually very surprised by how little testing has ever been done as far as to remove the actual snout, waveguide, tangerine, compression, horn array, and compare it to see what effects it has on the bare tweeter, for better or for worse, or for placebo reasons. And for the most part, I tend to believe they're all actually purposeful. I don't think Kef would actually install something that's just purely ornamental. And just visually inspecting it, you can kind of see what it does. But what I am interested in is how much it works. And by having a whole series of different generation add-ons compared to just pretty much not having one at all, and then applying maybe an old Unique to it, which I'll eventually do, which is bringing us back to the times before we even had these things at all. We would be able to figure out the whole entire evolutionary step from the dawn of the Unique all the way up to modern Kef with the Tangerine waveguide. So I thought this would be a pretty fun experiment. So this is just like, the maiden voyage as far as this odd little Abominator thing. It's crossed over just to protect the tweeter. So it's not gonna play anything lower than about 2.2. And so if you guys have any ideas as far as what we want to do with it, I can get it to play it down to 1.8 without it damaging at all. It doesn't seem to bottom out. Kef tweeter is actually very powerful. I actually played this thing is actually rated to I believe 100, but I have a feeling the same tweeter is actually used on the 200 wattage speakers. So I've actually played this thing up to 150 watts and nothing happened. It actually works fine, and I didn't go up any higher. I just kind of got scared and turned it back down. So you know how like the larger floor standards go up to like 200, and then have the gigantic banquet style crazy people spend $300,000 on their speaker style speakers that have the same size tweeter? Those are like 500 watts. So this thing is supposedly something between 100 watts to 200 watts. So I played it up to 150 watts and it worked fine. So I do know that it is of the same generation that falls right between the XQ and I guess the LS50. The main giveaway that it falls right between the two is its size. And the size is actually what makes it the most helpful for testing to see what it would show us between the transition between old Kef and new Kef. Because new Kef jumped to a full half an inch. Old Kef kept at a point what is it? I don't know exactly what it is in metric, but I'm just gonna call it, I guess, 3/4 of an inch. I don't know if that's exactly what it is, because I'm sure it's not exactly that. probably is English after all, so imperial. So yeah, it's 3/4 an inch. So that means that all the old waveguides actually work for it. All the new waveguides also work for it. What you'll find interesting about this tweeter in specific is that it's actually a very, very flat tweeter, because it was something that was done, I think, because, and I actually learned a lot taking this speaker apart. There's a lot of stuff that I even like didn't understand to begin with, and now I understand a lot more, and I'll probably cover that. But this is the flattest KEF tweeter I've ever seen. It's like they took a bowling ball and needed they needed 75, a 75th of an inch, and so they just sliced it from a bowling ball. If you look at this thing, kind of look at it like, from different angles, and then look at this thing. This thing looks like it was sliced from a freaking ping pong ball. It's huge. It's like not just huge. It's larger in terms of being a full inch, but it's also much rounder. And because of that, because it protrudes more, you can see that the fins and the flare of the horn is wider. The wider flare then is able to direct all its tangerine waveguide goodness directly at this, the outer waveguide. This was actually removed from this guy. And this guy right here has a very, very flat waveguide, but a very, very recessed horn, as you can see. The horn has very, very long, but very thin, thin in the front, but thick in the back, fins. I count, let's see, what was that, 5, 9? And I count, what was that, 7. So, yeah, so there's 7 fins here and 9 fins here. The biggest difference is the depth. So not only is the size of the tweeter larger, but it's actually just rounder. And so the waveguide extends further outward. In terms of, if I were to consider this just an XY axis, the horn is flatter and sprawled out more, so that it lines up. If I took a laser, it would actually line up exactly with this right here. This right here is basically this it's called the Z-flex surround, right? So basically when it goes through its maximum excursion, it's only gonna flex from the inside rim, and the outside rim is gonna stay stationary, allowing the outside rim to always perform as a outer waveguide. And I'm gonna do that trick that I showed you before. What's really cool about all KEFs up in, basically, actually all KEFs, because it hasn't really changed. New KEFs are defined by flare, cutoff, and then something here. Old KEFs are defined by flare, flat rim, and then a surround. That's pretty much the way you tell the difference. New KEF, how do you know? Flare, something around the outside. New KEF. Classic KEF, how do you know? Flare, but then, hey, flat rim, and then a surround. The surround never needed it to be flatter. It never needed it to be anything but a regular butyl surround that you could just buy from anything else and replace from anything else, because it handled all that the modern KEF would handle on the other side of the surround, and using the surround itself by actually using this flattened rim around the outside of the flare. The flare actually ends right here. So the driver is actually pretty small if you were to actually just deduct the actual outer rim. And that's essentially what they did. They raised the size of the tweeter, and they just shaved off the portion that would be the thing that would merge the tweeter and the woofer to get rid of the shotgun effect. But besides that, let's jump back. Oh yeah, bonus question. What the hell are we looking at here? Flare? Not even really much of a surround, more like a gasket. And then a whole crap ton of stuff going on outside of the flare. And remember, this thing is actually not even meant to be visible. This thing actually usually has a mesh grill over it, so you can't even see it. So this is not meant to be aesthetic. It's meant to be hidden. But it does its damn job, and it does a really good job at it, and it makes it work as if the whole entire thing, as opposed to having so a flat region exists outside. They put the flare at the end, they put the surround at the end of the flare, and then they had it so that outside of the flare, where the flat rim used to be, is now a fully fledged waveguide. So the whole entire baffle behaves as a waveguide. So this was actually one of the earlier attempts at using this technology so that you could effectively make it so that the entire front baffle of the driver performs as if it is the sound source. So this thing in practice is pretty cool. When you place it down, I actually have it wall mounted because I like using it as surrounds. But when you place it down, it points naturally upward a little bit. But since we hear left and right, like widescreen, when you have these in stereo, these things actually sound as big as they are tall. So as opposed to the driver sounding this big, it sounds this big. And since you place two side by side, they actually have this extra little hook right here. Doesn't really matter. But if you play two side by side, then you're going to get a widescreen effect anyway. So you get the whole entire baffle as an acoustic surface, which is pretty sweet. So yeah, so this passes and is classified as being NeoKEF, even though it doesn't even have a Tangerine waveguide. It has a similar tweeter as this guy, which is actually a similar tweeter to this guy, which is where we got this outer rim. So all these were 0.75 inch surrounds. And what I found pretty interesting about this is that even like the design of their center speaker, this is a nice center, by the way. I always loved it, and this is pretty much one of the reasons why I'll never get rid of this thing, because I just think that unless they create something better, which they kind of have with the 3001 SE center, but it's just not like quite as large enough to fill up a whole entire theater or a home cinema. But I love the way this thing is like rounded. That's just rad. But you'll notice that because this thing is designed to listen to on access from the front, they don't even have a flat rim. Well, they do, but look how minimal it is. It's like tiny. It starts like right here, ends right there. The flare goes from here all the way to here. So this is already kind of moving toward like what a modern Uniq would be. But it still doesn't have the Tangerine waveguide. So the sound is still very different. I almost want to remove this and add a Tangerine waveguide to it and hear the difference. Nonetheless, I have this, which is the same thing, and it's meant to be a main, so it's meant to be listened to off access. What I showed earlier is that when the way this works is that in the classic Uniq fashion, the purpose of the Uniq was not to just put a tweeter in the center of the it's not a coaxial. You don't just put a tweeter in the center of a woofer and then call it a day. The purpose of this design is to allow the woofer itself to complement the tweeter in such a way that when they are both at the crossover, the woofer actually behaves as a waveguide to the tweeter. So at any given point when they are both playing, pretty much was just, unless you're listening to sweeps all day or you're just R2D2 communicating, you are always going to be hearing the tweeter and the woofer at the same time. There's something called the shotgun effect, which is something that is always plagued, and there's a reason why no one actually does this design, because whenever they try it, they always end up with the shotgun effect. HSU even tried doing a I guess coaxial. I save the word coincidental just because that's what Kef calls this. So otherwise, I'll just call them coaxial. But this isn't coaxial. I call it coincidental because the tweeter really is actually placed right at the throat. A coaxial is wherever the tweeter is placed in the front or in the rear, like a tannoy. So anyway, the tannoy does a pretty good job. It uses the horn and tries to use timing mechanisms, stuff like that, to try to do the same thing. But anyway, the tweeter plays extended, following the path of least resistance, using pretty much the same, logic as any waveguide. Look at the Rendels, which are basically just take this thing, unplug the woofer, and then pretend the woofer is just a waveguide, and then bam, you have a Rendell. Anyway, so when you're playing this thing, the air pressure is normally gonna follow and crawl because there's basically air pressure is pushing always against the surface, right? It's gonna be bounded against the surface, just like the same way that when you put your finger between, like water, like a faucet, it's gonna draw your fingers together. So air is always clinging up against. That's why the edges have edge diffraction. When air is being pulsated in and out, it's not just being pushed in and out, it's actually being dragged from the top, the bottom, the left, and the right. And that's why Care was actually done to add this hunk of metal on top that was round. And I actually just added this for fun, just because if I tilt it and I, actually knock against something, I don't scratch it. But it doesn't really make a big difference because there's already a shadow flare type thing right here. So these things right here prevent there from being any sort of drag. But if left to his own device, if you look back at the LS3 5A, you'll notice they actually added a whole felt square around the tweeter. And the reason why is because they actually had a design made out of birch that was sunken into wood. And so when you have all this energy being blasted in and out, it's gonna drag air on the X and Y axis. On the X and Y axis, if you drag air in and out, what you're essentially doing is you're turning air into the equivalent of a bow on a violin. And all the right angles, you're basically strumming. So every single right angle on the LS3 5A, you'd be strumming, and you'd be causing secondary radiation sources that smear the sound. So what they did was they added a felt square around the tweeter, and since the woofer is a much larger wavelength, it didn't really need that. On the 207, they just made the whole entire thing rounded. They got rid of all the flat and 90-degree angles, and that's how they solved that issue. On the newer ones, they added this flare. They added the really cool copper hood, which not only makes it so the top is a lot more structurally and has more structural integrity at the highest point, which makes it so that when even if this thing's pisting at full power, it doesn't resonate any energy all the way down, which keeps it playing much cleaner. Look how far the hood goes all the way back. And this was actually adopted from the 207, just like the fact that the whole entire back is one bowed piece of wood allowed for the port to have no issue with standing waves, so that way any sound coming from the port sounds really clear and pure and cool. It's very well integrated. And I always have to point this out, but for any math geeks out there, you notice an interesting ratio. What is the ratio of here to here? This is a sealed compartment. To here, which is a sealed compartment. To here, which is a sealed compartment. You probably know what ratio that is. Now look at the XQ series. Now look at the blade. Look inside the blade. Look at the 207s. You're gonna actually be surprised by what you find, because it's a very, very clever design that prevents standing waves, and it prevents even standing waves outside, as far as like what is radiated out from your woofers. Even if you're facing it out of the wall, the actual output would actually end up producing an irreducible wave. It wouldn't just build up a certain wave. It would actually just basically keep, this woofer here would essentially break the continuity of this woofer here, because these two, even though they're in parallel, would never ever play in direct parallel. This would always play a little bit behind, almost as if it's like, 6 inches behind, or maybe 1.6 inches behind. So what I want to do is do a full analysis, because I've never really seen anyone do it, but a full analysis on what effect the Tangerine waveguide really had. And I know for a fact that it does make a difference, because I've tested it and it does. It works. It actually does sound much better with it than without. And in fact, not only does it sound better with it than without, it's very clear, especially between two speakers, that the design of that Tangerine waveguide solved exactly the issues that I had with the first generation of that speaker, down to a T. Almost like a freaking magic genie made it or something. It was really bizarre. Anyway, back to the other. Also, I like doing this. Pull out your spectrometer. Listen. Listen to how that's exactly the same tone. Like, you know how you can pitch drums? I forget exactly what note that is, but it's literally the same exact note. I just thought it was a nice little feature. You could figure that out on your own with a spectrometer, or just, listen to the recording and you'll figure that out. Oh yeah, and they don't all sound the same. Beep, beep, beep. Boop, boop, boop. Beep, beep. Boop, boop, boop. Beep, 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 beep. So you don't have to hear that this is a much lower frequency. It's also tonally matched. Whew. That's surprising. That's the same note. Huh. I didn't know that. Okay, so this thing doesn't actually have a woofer, so it doesn't have anything to actually compare itself to. But this was the first time Kef was able to make a speaker that was free to play, so that the woofer could actually play all the way down as low as it needed to go without actually obstructing the tweeter. Because the tweeter before would rely on the outer rim of the woofer to direct or basically merge the sound of the woofer and the tweeter and sound as if it's one continuous sound source. And that would eliminate what would be called the shotgun effect, the dreaded shotgun effect. If you want to know, and I don't want to cast dispersions or anything, but because HS Zoo, I think they're pronounced, or just Sue, they're great, and don't sue me. But yeah, HSU makes really, really good and actually surprisingly innovative subwoofers. They tried making something called the CCB-8, which kind of sounds like the Star Wars creature, And they were actually their first attempt at making something that was pretty much like this. The issue they had was due to not having the expertise. They've been designing these things since the 1980s. And so not having the expertise of creating a single point array, they would put the tweeter in the middle of the woofer. And they had horrible shotgun issue effects. So, if you're right in front of it, you hear a much more abrasive tweeter. Whereas if you're at the side, you wouldn't hear that as much. And so they even created this kind of weird Band-Aid fix where they had they suggested that you point the speakers like towards in kind of a pigeon-toed fashion, so that this speaker would be pointed like that way, and that speaker would be pointed like that way, and then so that way you would never ever be in line with the tweeter. And I don't think anyone really went for that, so I think that speaker series didn't do that well because of that. But what's cool about the way this is designed, due to the flare, is that not only is that no matter what, this horn will always line up with the outer rim of this waveguide. This Z-Flex, as they call it, surround, is actually not just a surround, it's actually the flat outer rim of what was the classic Unicue's way of merging the tweeter and the woofer. Now it's actually an active element. It works both as a surround and it works as a active acoustic element. So what's cool is that when I first heard these speakers, I actually noted that I could hear the tweeter, but I was listening to them this up close and at a lower volume. And that's not what I was used to, because I was used to listening to the older style Unicues. And so I was kind of disappointed because typically you don't really hear the tweeter by itself. So I was kind of thinking maybe the tweeter is just bigger and that's what they're doing. But actually that's not the case. Normally with cap speakers, you're supposed to toe them straight and you're not supposed to even just listen to them dead on anyway. So when you listen to these things dead on, yeah, you can hear the tweeter apart from the rest of the speaker. If you turn it up, however, then that's not going to be as much of a case. You back up, it's not going to be as much of a case. But what's actually most interesting is if you do this. Try that. Suddenly you'll hear the tweeter migrate to here. And then to here. That's the whole entire point of the flare of the tweeter. And the additional tangerine waveguide. By adding this tangerine waveguide, it equalizes air pressure across the entire tweeter dome, so that even the outer edge of the tweeter is able to be as efficient and to disperse. I think it was like 20% wider than typical. Whereas before, the center would have a hot spot, and like with any dome that's pistoning, the outer rim would kind of just graze the air happenstantially. The original snout or horn dealt with that, or at least tried to deal with that by adding more air pressure there. But through computer-aided design, they were able to create this very specific design that was pretty much just like a reverse lens. It's like an aero lens that would then allow for air that's pistoning in and out to be flat across the entire surface dome, whether it be the rim or the center, getting rid of the hot spot to the point where there's actually even like a little thing in the middle. But yeah, try this for yourself. It's actually kind of a neat experiment. You can hear the tweeter come from the center, then do this. What you hear is now the sound is coming from here. But then what you'll hear that's even more interesting is if you back off, the sound starts to actually sound like it expands because it's doing its job. So once you back up far enough from any angle, actually, now what you're really hearing is the tweeter's extension, the dispersion, casting against this outer flare here. This outer flare here is active, so any on-phase action is then casted forward as if the outer flare is not just a waveguide, but pretty much like a gigantic ring tweeter. Not only that, but regardless of how much excursion the low frequency driver has, which allowed for this one single speaker to outperform the XQ10s and XQ40s in terms of depth, was due to the fact that the tweeter and the woofer were able to interact completely independently, so that the woofer can be played with much more maximum excursion. So that allowed for this speaker here to go all the way down to an in-room performance of about 40 hertz, which was unheard of before for a single UniQ driver design, even with a port. And that all came about because they basically cut off the outer flare, made it so that the outer flare was integrated onto the surround and outside of the surround, which freed the woofer to go nuts and play as low as it needed to go. Meanwhile, no matter how nuts the woofer would go, no matter what, this flare here would guarantee that the dispersion would meet at the outer rim, and then you would still get a unified sound as if the tweeter was coming from the whole entire driver. And in even more advanced designs like this, the tweeter would actually sound like it's coming from the whole entire baffle. So you would actually get a sound almost as if, literally as if, I guess is why people call it holographic, right? It sounds like the driver is about this big, and then when you back up, it becomes like this big, to the point where you can't really even tell where the speakers are coming from anymore, and that's what's called the vanishing act. So, yeah, that's like a whole gigantic amount of evolution in 3 steps that occurred, I think, in about 20 years. And I think I'm gonna do some reverse engineering to figure out how that happened with this thing, because this thing just so happens to have all the parts needed to do tests to see how they did that. So I hope you have any questions and any ideas, and if you have any other maybe parts you could send in that I could test, that'd be kind of cool, because I've never actually seen someone remove or dismantle a UniQ to this extent before, where you could actually do so much testing on it. And I think doing testing on the way that a Tangerine waveguide works would actually be pretty damn interesting. And I'm really surprised that, though I read so many reviews that have testified that they have that they work, or measurements that attribute their improvement to the Tangerine waveguide, I've never seen anyone actually do an A/B comparison of just removing the waveguide and then doing a test, and then applying the waveguide and then doing another test as a direct A/B comparison. Similar to how I have issue with the new MetaTech or MatTech, of how there's no way to tell whether or not it works, because no one has ever tested a LS50 without the MatTech versus the LS50 with the MatTech. And the LS50 with the MatTech has technology that would account for the smoothness that would not require the MatTech to even exist. In fact, the smoothness that you hear predates it and could be found in the LSX and found in the 3001 series. So I find the MatTech suspicious, and I find it to be a further evolution of the experiments they did with the HTV2 and the HTVW. So I'll elaborate on that later on. Anyway, welcome to the what I call it before, the weird, I was call it, give it a new name, the weird chimera thing. And thank you.